Oh my gosh. Okay, hey guys, this is the first video for Unit 5. Unit 5 is our functions unit. It covers 8th grade functions section 1 through 8th grade functions section 5. So the first lesson is 5.1. It's just called functions. It's just kind of an overview of functions. What are they? How do I know if it's a function? That kind of thing. So we're going to hit a couple of key words here, some vocabulary words. Then I'm going to skip down to relation first. And a relation is just, it's a relationship between two or more sets of values. So in our case, we're going to think of it as a set of ordered pairs, even though sometimes it's not always written as ordered pairs. So it's a set of ordered pairs. It can also be written as a table, or it can also be written as a mapping diagram. But it's always going to be ordered pairs in the long run, right? Because a table is just ordered pairs written in table form. A mapping diagram is just ordered pairs written in a mapping diagram form, okay? So basically it's a set of ordered pairs, but it's also, I don't want you to think of it as just ordered pairs. You can see it in a table, you can see it in a mapping diagram, you can even see it in an equation. Okay. So knowing what a relation is, then we can go back up to function. And a function is a relation, so it's a relationship between two or more values where each x value is paired with exactly one y value. Okay. Our input are the x values in the relationship, also known as domain. So there's lots of different words for it. We're going to talk about it as input or x values this year. Next year, you'll talk more about it being domain. And then the output is the y values in the relationship, or the range. And again, the range is, you'll hear that more in 9th grade. Then the last little vocabulary word that we're going to talk about is a vertical line test. And a vertical line test is what we use to determine if a relation is a function. Now remember, vertical is up and down. Okay, so sorry, I had a phone call. I'm totally distracted now. Okay, let's talk about how to determine if it's a function based on what type of relation it is. So let's talk about tables first. So what we're looking for is that each x value in the table has only one y value associated to it. So the y values can repeat, but the x values can't. So if I look down my x column here, over here on the one that says function, you can see that I have a 0, a 2, a 4, and they match with a y value. And there's not a double 2 or a double 4 over here on the x's. Okay, so that makes it a function. Now, if you look over here at this one under not a function, you can see that we have two 2's, and they are assigned to two different y values. One has a 10 and one has a 2. So this is what makes it not a function. Right here, the fact that there are two 2's or two whatever, or even 3 or whatever, okay? There could be any number of them, but that's what makes it not a function. Okay, same thing with ordered pairs. Each x value has only one y value, but it's okay that the y values repeat. So remember, with ordered pairs, the first one is your x, so that's what we're looking for to make sure it doesn't repeat. So you can see that none of these repeat, okay? So that makes it a function. Over here, again, the x values are first, so that's what we're looking for. You can see that right here I have two 3's, and they are assigned to an 8 and a 10, so that's what makes it not a function. Okay, with mapping diagrams, again, they're just ordered pairs, just written a different way. So the arrow shows you the ordered pair. So see this arrow right here? That means that the ordered pair is 1, 6. Okay, so this is my x and this is my y. And again, it's that each x value has only, and this time it's one arrow attached to it. So what I want to do is I want to look right here and see that each of these numbers only has one arrow coming out of it. If you look over here, you can see that this 2 right here has two arrows coming out of it, leaving it, and that's what makes it not a function. The fact that there are two arrows leaving the x column and going to two different y columns, two different y's. Okay, graphs. Graphs, what we're going to do is use the vertical line test to see if it's a function or not. Okay, so if the vertical line is drawn, it will only cross the graphed object one time. So I'm going to zoom in and I'm going to just draw a random vertical line. So there's there's one. I can draw it anywhere I want. And you can see that every time I draw a vertical line, it only crosses my graphed object one time and one time only. Okay, if I come over here and I graph a vertical line right there, you can see that it crosses my graphed object there and right there. And so it crosses more than once. And so that's what makes it, it's not a vertical, or sorry, it's not a function because it does not pass the vertical line test. Okay, passing the vertical line test means that it crosses only one time, not more than once. Okay, with an equation, if the y is squared, if the y value, nope, variable, the y variable is squared, it won't be a function. Also, if it's a x equals a number, because that's a vertical line, and yeah, that's it. So x can be squared, that's okay, and it can be just y equals a number, that's okay, and just your basic y equals mx plus b equation is perfect. Those are all great examples of what it is to be a function. But you can see over here that this one's got the y squared, and this one is x equals a number, and so these ones would not be functions. Because x equals -3 is a vertical line in and of itself, and so it would not pass the vertical line test, because then if I drew a vertical line over it, it would cross in every single point all the way down the line. Okay? All right, so let's practice, and then it says explain why or why not each representation is a function. Okay, so with the table, I'm just going to look at my x values and make sure none of them repeat. So I have a -7, a -5, oh, a -7. I have two -7s. Okay, so this is a no, and it's because of those -7s. Okay, the x, it repeats a value. Okay, remember with an equation, the x can be squared, but the y cannot. So since this is x squared, this is a yes. And it's because the y squared is, or the y is not squared, and it's not x equals a number. So it's not, it is a function. Okay, with a mapping diagram, I'm looking to see that there is only one arrow leaving each of the x values. And since there's only one line coming out of each value, this is a function. Okay, with ordered pairs, I'm looking at those first numbers only and making sure none of them repeat. And you can see that I have two 9s right here. And since they have different y values associated with them, that is not a function. Okay, so just a couple more and then you guys can do the rest. I haven't done a vertical line test one, so let's do this one right here. So if I draw a vertical line through any part of this graph, you can see that I hit it more than once. Now, if I was to draw the vertical line here, I would only hit it one time, but I have to keep checking. And so when I draw my vertical line anywhere else, I cross it like 1, 2, 3 times. So that would be a no. Okay. So I'm going to have you guys do the rest of these and then pause it and finish it, and then you can come back and check your work. Okay. Okay, so those are done, and I kind of circled the reasons. If it was a no, I kind of circled why. So like, for example, this one can't be an x equals a number, so that's why this one had 2 lines coming out of the -2. This one right here was a y squared. This one had 3 6s in the x spot, so that's why. All right, that's it, guys. Thanks.